Hi guys, this is Mayurved. In this video, we are going to learn about the strategy pattern. So let's get started. Strategy pattern is a behavioral design pattern. Strategy pattern defines the family of strategies or algorithms, encapsulates each one and makes them interchangeable, and so provides a capability to switch between the algorithms at runtime. Instead of implementing a single algorithm directly, code receives runtime instructions as to which one in the family of algorithms to use. Strategy pattern basically prevents hardwiring of all the algorithms into the program. The key idea is to create objects which represent various strategies. Here by strategies, we mean algorithms. These objects form a pool of strategies from which the context object can choose and vary its behavior as per the chosen strategy. All the strategies belong to the same family of algorithm must implement the same interface, and that interface basically defines the contract between the context and the strategies. The interface captures the abstraction the client wants to exercise, and the implementations of that interface are effectively hidden. The strategy pattern is also compatible with the solid principles. The strategy pattern is used extensively to achieve the single responsibility principle and the separation of concerns. How? Related behaviors and algorithms are separated into classes and strategies. This pattern is also based on the open-close principle. We don't need to modify the context, that is, the context is closed for modification, but we can choose and we are free to add any new implementation, that is, our design is open for extension. Didn't understand much from the definition? No problem. Let's understand the strategy pattern using an example so that we can get more clarity. So let's say we have a route planning application like Google Maps where users can enter the source and destination address, and then our app will help them to find the fastest route by road which they can follow to reach the destination. So this is the basic view of our navigator class, where we have get current location method which returns the user's current latitude longitude coordinates. We have get current address method which returns the user's current address, and we have get routes method which is our main functionality of our business application, which returns the routes to the destination from source. Now let's say we have a business requirement to return the fastest route to the destination by foot, two-wheeler, bus and metro public travel as well, apart from the road travel. Users can give any mode of transportation according to which we have to return the route. Now each time we get a requirement like this where we need to support a new mode of travel, we will be altering the code of navigator class, which is against the open closed principle of solid principles. The open closed principle states that software entities should be open for extension but closed for modification. Also, adding a new routing algorithm to the navigator class, its size will increase and at some point it would become too hard to maintain. Also, any change to one of the algorithms affects the whole class, increasing the chances of creating an error or bug in already working code. Now let's see how we can apply strategy pattern here to get rid of all the issues and simplify things. Here we have a family of routing algorithms within the navigator class, and we may require to switch from one algorithm to another at runtime based on the user's requirements. To understand the strategy pattern, let's look at its principles and apply them. Design principle 1. Identify the aspects of your application that vary and separate them from what stays the same. Encapsulate what varies into their own classes. So now, in our navigator class example, the getRoutes function vary according to the mode of transportation and everything else remains the same. Now this getRoutes function can have multiple behaviors, like we want to get routes when we are traveling by road, we want routes when we are traveling by two-wheeler, we want routes when we are traveling by Foot, we want routes when we are traveling by public transport like bus and metro. And so it can have any behavior at runtime based on the client's requirement. So in the strategy pattern, this aspects is basically a family of algorithms, and it can use any algorithm from the family of algorithms at runtime. So coming back to our example, we separate this get routes from our navigator class and keep this get routes function inside a different class. This way, the navigator class will delegate the work to the routing algorithm road class instead of executing it on its own. This will allow us to add new routing algorithms or modify existing ones without changing the code at doesn't vary. We will need to link the navigator class to the routing algorithm. Later in the video, we will see how we will achieve it using composition. Design principle 2. Favor composition over inheritance. Inheritance binds us to a specific implementation that either comes from the parent class or is overridden by the child class. This is not desired for our purpose in strategy pattern. So let's say in our navigator class, we would have inherited the routing algorithm road class, then we would have been logged with the implementation that comes from the routing algorithm road class. Instead, we are going to use composition over here. Composition gives us a lot of flexibility. To find out how, check design principle 3. Design principle 2 and 3 often goes together. So design principle 2 is incomplete without checking design principle 3. Design principle 3. Program to an interface, not to an implementation. So as I told you earlier in this video, design principle 3 basically completes the design principle 2, and design principle 2 and design principle 3 are often applied together. So here in our example of our navigator app, the navigator class will basically be associated with the routing algorithm interface instead of its implementations. So in the navigator class, we will declare a variable that will be the reference to the routing algorithm interface, and the object assigned to the reference variable can be of any concrete implementation of that interface. Thus, we are not binded to the implementation of an interface. Instead, the navigator class doesn't know about the actual object types. This allows us to change the behavior at runtime using dynamic polymorphism. The navigator class has a method for switching the routing strategy. So in general, design principle 3, that is programmed to an interface, not to an implementation, allows us to change the behavior of a program at runtime by exploiting the power of dynamic polymorphism. The interface signature determines what all operations can be done. Think of an interface as a contract between the implementations of the interface and its clients. That is, the interface specifies the operations that the classes implementing it can do and the signatures for accessing those operations. So finally, after applying strategy pattern, our design is going to look like this, where we have separated out the getRoute method from the navigator class. Now the getRoutes method basically varies according to the mode of transportation given as input to us by the client. Now each version of getRoutes method is encapsulated within its own class. All the versions of getRoute methods, which basically belong to the same family of algorithm, implements the routing algorithm interface, and the routing algorithm interface is now associated to the navigator class through composition. The navigator class is basically called context in strategy pattern, The context doesn't know much about the strategies. It doesn't know what type of strategies it works with or how the algorithm is executed. Also, the context isn't responsible for selecting any appropriate algorithm. Instead, the desired strategy is passed to the context by its client. Context works with all the concrete implementations of the interface which it refers. This way, the context becomes independent of concrete strategies. So now, basically we can add or modify existing algorithms without changing the code of context or other strategies. So summarizing the strategy pattern, we should use the strategy pattern when we want to use different variants of an algorithm within an object, and we want to able to switch from one algorithm to another during runtime. If you have any doubt regarding whatever we have discussed in this video, feel free to write it in the comment section, or if you think that I have missed something, feel free to write it in the comment section and I'll try to address it. Till then, bye bye, take care, keep learning, see you in the next video.